Hello everyone, welcome to Release Automation. Today I'm going to explain to you how our journey at Get Your Guide looked like to a fully weekly automated release, and especially about our challenges and how we solved them along the way. My name is Marjana Karzek and I am a senior mobile engineer at Get Your Guide. Once upon a time, this is how all the good stories start, so let's dive right in. In 2023, this is what our release process looked like. Usually we would develop until Friday evening, and then every 2 weeks on the Sunday evening, our CI would build a release, and then we would be able to manually test it along Monday, Tuesday, and Wednesday. After that, we would start an incremental rollout and distribute it to our users. But this is like the good and happy path, right? We would have a release captain who would regularly look at this sheet, and they would make sure that for each feature listed, all the tests would be completed, and if any issues would be found, they would be reported to the responsible code owner and fixed. The whole team would be involved. We would have a rotation, so each week or each release, we would test different features to ensure that we don't have test bias, and this would take an engineer up to several hours, because depending on how big the feature was, there would be also, and how important the feature was, there would be also a lot of tests. The release captain would also nudge the people if they wouldn't perform the tests and manually do that, some additional tests that are listed down below. This is what a test sheet would look like. As you can see, loads of tests, loads of data. Unfortunately, we often were confronted with outdated tests and inconsistent formats, especially when a new feature would be introduced. People would have a separate document for the tests in different cases with different data, and that would be increasing the complexity of running the test cases. Also, the test data would often not be reliable, activities not found anymore, or user data outdated. If a bug would be found, they would have to coordinate with the code owner to fix it, and often enough we weren't 100% sure whether something would be a release blocker or just a bug that can be fixed along the go, so there would be a lot of headache involved here. If a bug would be found, of course that would not be done on a Monday. Of course we would find it Tuesday evening, and then we would have to go fix it, and then create a new release build manually with a release captain, and then put it into review. Once the review would be completed, we would be able to then proceed with the rollout, but not before we wouldn't validate it again. So a validation would take us until Friday in the worst case. So of course we don't release on a Friday, we only release then on the Monday after, and that would result into a bug being found, extending our rollout by up to 4 days due to the weekend. And that's only in the best case scenario. You can imagine how it goes if there are vacations and public holidays in it. Also, leave of people, high season for vacations would lead to the manual validation taking even longer. So we would also often enough release only the week after. Since we don't have a QA team, that would not be something that would be covered by someone else. The release captain was often confronted with a failing CI. Usually this was due to our main branch not building, or due to our UI test not being properly executed and being flaky. And if we were very unlucky, also our Google Play Store API would be down, and then they would have to fix the tests and make sure that they work again, also our main branch, and then do all the work all over. This would not extend our release too much, but it would make sure that the release captain would be covered in work and manual work and not be able to work on the features. Usually, on average, from merging a feature to a 100% availability for our users, it would take us 21 days or even longer. That would be especially annoying to our product owners who are always releasing features with us with experiments. So until they would be able to have a significant significant amount of data to evaluate whether a feature would be working or not, it would take them 3 weeks or longer. If there would have to be done a fix on the feature because our manual test would not be 100% reliable, we would have to wait for the next release train and then fix the feature, toggle it off, fix the feature, release again, and then another round of release would extend the whole process by 2 weeks. There would also be no way of patching something easily, which especially product owners of web engineers would love to have. So they were very pushed back with a bi-weekly release. It often led to engineers being especially stressed on Fridays before the release, as they had to quickly push out features and quickly finish them up, often leading to even more broken features and then even longer extended rollouts. And of course, mental stress that we would like to avoid. And yes, this diagram can be even longer. In the extreme case, it would take us from finishing a feature up to 25 days to fully roll it out to 100% of our users. So not a really ideal scenario. But fear not, there's even worse if you're the release captain, because in the happy scenario, you only have to check the status manually of the release, and you can then incrementally increase the rollout percentage and notify the stakeholders in our Slack channels. But if something goes wrong, then you have to manually stop the release, notify the owners, make sure that the hotfix is going out, and then go through the whole process of manually testing it over and over again. So a release captain would be really occupied with work. As of today, we're having a much nicer scenario. Again, we're developing until Friday, and then on Saturday night, we're automatically releasing to the Play Store. It's gonna start rollout at 1%, and on Monday, we're gonna check whether the rollout is going successfully with our automation, and if so, it automatically increases to 15, 25, or 100% in the week after. And this allows us to reliably release every week, which especially makes our product owners very happy. Our release captain has almost nothing to do anymore because all the work is automated, and only if something goes very wrong and there's no replacement for the team, they might have to step in and make sure that the hotfix is being released. But this is now much less likely than before. So now you're probably wondering how we achieved that. First of all, we needed to identify what are our goals. We needed to have the same confidence in our tests as with our manual testing, or even better. We wanted to know if something goes wrong early on. We didn't want to know when we come to work back on Monday at 9 a.m., first thing we see, broken release pipeline. No, we wanted to know as soon as we might introduce a problem. And the third thing, we wanted to automate everything. We didn't want to touch it anymore. That left us with 3 main areas for improvement. First of all, our testing strategy was already good for feature development, but it was not covering well our release strategy. So we needed to make sure that this would be solid. The second thing we needed to improve was our continuous integration, because it could not randomly and regularly fail anymore if we want to automate it. And then last but not least, all the work from rolling it out needed to be automated. Let's have a look at our testing strategy first. We already had UI tests, but they were mocking the backend response, and therefore they were not 100% mirroring what we were achieving with our manual release validation. Plus, they were super flaky, they were hard to write, and they were very hard to maintain, especially for people who were foreign to the domain of the tests. So if something would break for some engineer on vacation, what probably would be the first thing to do would put a thread sleep into the test and hope for the best. No one understood them anymore, and everyone hated writing tests, which is not a really good way of approaching that. So we decided to go with end-to-end tests for our least critical user journeys. We are leveraging 3 tools here. One is Caspresso combined with Jetpack Compose UI tests, then Flank and Paparazzi. We were tracking our progress in our testing sheet, so it had a last time to shine. And iOS was also tracking their progress at the same time, so we had a little bit of a competition going on. Unfortunately, they won, which we're gonna pretend that they didn't. Okay, so Caspresso is very nice. It's made by Kaspersky Lab, and the interesting part about it is that it has a built-in flakiness protection. It uses a declarative approach for writing tests and is very human-readable in the end. We were writing our tests before with Espresso, so we were especially happy that migrating it to Caspresso was very simple and straightforward. This is what a test would look like after the migration. On the left, you can see the familiar construct of an Espresso test with all its nestedness. And on the right, you can see how straightforward you can identify what exactly is going on in that test with one look. And the crucial part to writing Caspresso tests is to define the screen that you're working with. This is an example of an XML screen, but you can also recompose screens with it. You would define what fragment to expect and what view to expect. And in order to access the UI components, you would have to define them like this, so you can use them in your test. This is what a full test would then look like. You have a very handy section for what should be executed before the test and what should be executed after the test. And in the run block, you would define steps. For each test, you would split it into smaller chunks, and then you would access the screen with its components and apply the assertions. Down below in the edit block, you can see how the flake safety would be performed in action. You would have a timeout after which the test would fail, and the test would automatically in rotation retry to check for the view before performing its assertion on it or finally failing the test. This leads to very handy logs. So you can see here very nicely what steps are being executed for your tests. Even someone who is foreign to the domain can then see exactly what failed in the test and where to look for, and then being able to fast and easy maintain the test if necessary. Also with Jetpack Compose, it's also much faster, much easier now, much faster to write your tests. You are able to use the waiting functionality to make sure that the same flakiness protection is in place. And we are very happy with the combination of it, so huge recommendation to leverage those tooling. We are using Flank. It's a test runner for Firebase Test Lab, and you are able to write a code config for it and provide it with your project. This allows you to parallelize your tests, so you don't execute them, your end-to-end tests or UI tests sequentially anymore, but you can also define in what groups it should run, and especially handy, what if it fails, should it retry and how often. This is especially important for cases where something on the backend is flaky and that you cannot protect with your Android code against. You can also define on what devices you want to run, and you can export your results, which we are leveraging to connect to Slack for personalized notifications. So we connected it to our code owners, and that allows us to notify the people directly who are involved in fixing an end-to-end test if it fails. It's also fairly cheap, so for running all our end-to-end tests, we spend 17 cents in US dollars. And it takes about 7 minutes to run all our tests from starting the job to finishing it. and 15 tests roughly take a minute to execute. That's still a lot, so be mindful about what you want to test. It still has the same disadvantages of the UI test of having to run it on the emulator or actual physical devices. And so be mindful, maybe you can combine some tests that you would usually perform in a single test each as a flow test together for a user journey in your end-to-end test. We have moved the UI validation from our UI tests into unit tests with the help of screenshot tests. So we are leveraging Paparazzi, which is a library from Cash App. It verifies our view states, so we have a lot more view states that we can fast and easily check. There's no emulator needed anymore, and it works like this, that a test generates a screenshot, and then our CI just verifies against that master screenshot for eligibility. We also have written our own Android Studio plugin and open sourced it, so you can have this very handy preview while writing your tests, which wasn't there before, so feel free to check that out. This is what a test would look like. You can see that with our compose views, it's very handy to just provide the view function and then, or the composable function, and then provide the state that you want to test. We are not only testing our light and dark mode, but also different font sizes and right to left support to support more accessibility on our application. You can also use your previews to write your screenshot tests. For us, that has not been too reliable. We often had issues to work around, especially because previews are usually used by us to make sure while developing that our views look good, and then they're often changed. So make sure that you're not messing that up with a combination of your development process, and otherwise just write your states like this, which is much more reliable for us. On our pull request, the automation just now verifies whether the UI is working correctly. This is how screenshots would be added to the pull request. You don't have to do this manually anymore for your features then. And due to that, it's very easy to review, and even our designers are reviewing our pull requests, especially when we're adding components like the banner alert to our design system. We're leveraging Git large file storage to upload our screenshots. So with this, we achieved our first goal of having the confidence in our tests, and we are even more confident in our automation because we know now exactly each engineer is no more skipping any tests because they have to get back to the feature or because they think the test is not so important anymore. Our automation ruthlessly runs all the tests and notifies us whether our checkout test is again broken or not. And so we are more confident now in our automated tests than in our manual tests we ever been. Many more states are now being automatically tested, and they even retry by themselves if they fail once. I'm not gonna lie to you, we were not able to automate all the tests we had in our release document. For example, for social auth, for Google, for example, we had trouble automating that because we could not click and enter the password into the UI that would be provided. So we worked around that by writing UI tests for these cases and then putting the functionality behind feature toggles and added monitoring. So usually it doesn't break and usually it doesn't change too often from our side either. And if it changes from our side, it will be caught in our unit tests and UI tests. But if something would be going wrong, we would be able to catch it with, or we would be able to disable it with our feature toggles and then fix it and then roll it out with the next version. This took us almost a year. It was quite challenging to find the time to automate all the release tests, but we got a lot of learnings out of it about how to write non-flaky tests. And it also influenced our processes, because now there's no more, discussion about whether we should be adding unit tests right now, whether we should add end-to-end tests right now at the end of a feature. If we don't have it, then we don't have any validation. So it's very clear to our managers, we need to put this into place, and there's no discussion about it anymore. With that, we could remove our manual release validation and could already increment then our rollout earlier. Up next would be to achieve a fast feedback loop, and that was done by optimizing our continuous integration. Everything can go wrong, so we needed to make sure that we're gonna be notified as early as possible. No more on Monday morning at 9, but actually as soon as we might implement a new problem. Our goal with that was to achieve an always releasable main branch. This is why we're running for all PR checks, our unit tests, screenshot tests, and UI tests and end-to-end tests, but not all of them, only the ones that are needed for the code that has changed. We are identifying what code has changed via the duck command tool by a former colleague of us that is still gonna be accompanying us through all our talks probably. So an engineer who would introduce a new bug or a new release critical issue would be notified right away, probably even before a review would be taking place, and then they could fix it. Additionally, we are leveraging the GitHub merge queue, where we're running everything. So for each pull request that goes into there and is being queued, we are running all the end-to-end tests and we're running all the UI tests, which leaves us free to not have to run them anymore on our CI build when we're actually building the release, because each pull request is being validated. And if something merges that, or if something is in a queue that would be failing our main branch, it's being taken out of the queue, so we know early on and not when we are building the release. Means we also have achieved our second goal of a fast feedback loop. We even could improve it slightly more. So while now our release pipeline would be super reliable, we now could move it to a more optimistic submission and submit it already on the Saturday. With that, we would be able to give Google more time to review our app and consistently increase our rollout, because by Monday, I think we haven't faced yet that it wasn't reviewed. So on a Monday, we can always increase then our rollout and don't have to worry about that part anymore. So two steps down. Now we needed to take away all the manual work from the release captain. And before we did that, we needed to make sure that all our release is being observed, that we have all the visibility of what's going on and and are notified in time when something fails. So first things first, we created ourselves dashboards or one dashboard in order to observe our application and our release status, and then make sure that we have all the metrics identified in order to know whether a release is successful or not, define the SLOs for it, and then create the monitors using Datadog. This also leads to our engineers in the teams being early on notified whether they might have to prepare a hotfix. Our most important metric for that is obviously the crash rate. So we're identifying this by session and by user. Then we automated our rollout incrementation. And we wrote a custom script using GitHub Actions. It's being triggered by a cron job and runs once a day. And we're using Google BigQuery to get the crash-free rate and then leverage the Google Play API to increase the current rollout. It runs once a day, roughly around noon. So we are usually able to catch anything that might go wrong and be notified about it. As I mentioned before, it's already rolling out at 1%. Which we are taking as a risk, because usually at 1%, nothing would go wrong too badly. And we would, if it would, we would know on Monday already and could fix it. Since we have now a higher confidence level, we were also able to reduce the number of increments. So we're now releasing at 1% automatically, but then increase to 15, 75, and 100%. In case something goes wrong, the rollout is being automatically stopped. We're running a script every hour for that. When nothing is going wrong, we're not being notified. But if we are, then the rollout is automatically halted and the team's notified. It's not being done by the release captain anymore. Don't mind that this being an iOS release that is being halted. Then every day at 9, we're posting a message automatically about the current release status and how it's going out. So all the stakeholders are informed. And if something would be going wrong, then that would be acted upon. Something we recently introduced is our fast tracking. So we are making a check after 15% whether we can increase to 75 or whether we can increase to 100% right away. We're leveraging this tooling, which you can find under this internet address, and we're calculating what the margin of error is, and if it's better than our SLOs, then we're gonna take a leap of faith and increase our application to 100%. The formula for the calculation you can also find on this webpage, because we have automated this by now as well, and it is being done automatically then to increase to 100%. It takes into consideration the crash rate per session, the number of sessions, and the SLOs. So with this, we have fully automated our rollout, and the release captain is very happy about this because they have very little to do by now and can concentrate on their features. Taking a look back coming from having to release every 2 weeks, hopefully, an Android release captain who would have spent a lot of time to coordinate everything and loads of hours going into validation and releasing our code, not even taking into consideration when a bug was found. We have now a reliable release every week. We have no manual work anymore for anyone except for the release captain, who would only have to act if something would be going wrong and no one would act on it. Everything is automated. The release tests, the incremental release, the checking whether the release is in good state, halting the rollout, and notifying all the stakeholders. And by now, from merging a feature fully to rolling or providing it to 100% of the users, it takes us 9 days. So it's more than 2 times faster, and especially our product owners are very happy about that one. Not even taking into consideration the delays by finding bugs. On average, it saves us 1.5 to 2 hours per engineer every 2 weeks, plus the time that they don't have to spend on fixing hot fixes. A little bonus, in case you're wondering what arguments best to use to convince your managers. You always need to know what is your audience. So understand where your managers come from. Gather the data that is impacting their impact on the company. So for example, how many bug tickets did you have due to the rollout not being proper? How many hours did you spend on fixing it? What did that cost multiplied by the hourly salary or even potential revenue loss? And compare that to the automation cost. Then, yeah, also check what your time to release features is and how this would be affected afterwards. Yeah, so I hope I could give you some inspiration to improve your releases. And yeah, in case you have any questions, let me know. Thanks for your attention.